Hello, everyone. I'm Shakil Mahmood, your physics teacher and helper. Well, today we're going to discuss one of very important papers, and that is International AS AQA Physics, Unit 1, Mechanics, Materials, and Atoms. And this is the most recent paper, May 2024. There are three sections of it, and I'm going to make three videos for it. In the part one, that I'm doing right now, we are going to discuss section A. So let's move to section A. As you know, there are a total of 80 marks in this, and it's really important that before you start attempting the paper, you should read all these instructions over there. So you're going to use the scientific calculator. You need a protractor as well. You need a ruler with millimeter measurement as well. And a data and formula booklet will be provided to you. And well, this is really important to carry a protractor, scientific calculator, and a millimeter ruler. And specifically, it should be 20 centimeter, not less than that. Can be 20 or 30, but this is the recommended one. Well, read the instructions very, very carefully. This will be done before starting the paper. So you have to use the black ink only. This is important, only black ink. And then, well, you have to answer all the questions, and then you must answer the question in the space provided. Do not write outside the box around each page or on the blank or on the blank pages which are crossed, right? So you're not supposed to write on that. And then then the line pages for your extra space. If you want extra space, then the line pages at the end of the document is given, and you have to write the question number, the part number over there, and then you can continue your work over there. And you have to do all the rough work over here. So this is very important to follow. Okay, so let's start with the first question of section A. And this question is from atomic and particle physics. So this is from atomic and particle physics part, the last unit of this paper. Okay, so they said that on an occasion, the electron and positron are created by pair production. It means this is the question of the pair production. When a high energy photon interacts with the nucleus of an atom, and then the data which is given is the rest energy of electron is 0.51 mega electron volt. So one thing, what is rest energy? You should know this. And second thing, it is given in mega electron volt. So rest energy is defined as the energy equivalent to rest mass of the particle. The energy equivalent to rest mass of the particle, and it is in MeV, and we know that 1 MeV equals 1.6 into 10 to the power minus 13 joule. This is not given in the data booklet. You should remember this. Okay. And if you want to write in only electron volt, not mega, then the power would be 19. So this is the thing. But as we are using mega, so we would be using mega over there. And then, of course, 13 will be over there. So what is the question? You have to show that the photon must have a minimum energy of approximately 1.6 into 10 to the power minus 13. This is 1 mark. 1 mark are generally easy because this is based on your basic concepts. Okay, so the situation is that a photon is coming. This is a photon, and it is going to interact with the nucleus. So let's say this is the nucleus. So when it interacts with it, it creates a particle, let's say electron, and an antiparticle, let's say positron. So this is particle and antiparticle are created. So what you have to show that this photon must have a minimum energy of 1.6 into 10 to the power minus 13 joule in order to create these two. And the rest mass energy of one of them is given. We know that the particle and antiparticle both have same mass, right? So particle and antiparticle have same mass. If they have same mass, they have same rest mass energy. So we say if they have same mass like electron and positron, then we say they have same rest mass energy. Same rest mass energy. It means that Both of them are having same amount of energy, which is 0.51 MeV and 0.51 MeV. So it means that the total energy is 0.51 plus 0.51. So the total energy would be 1.02 mega electron volt. So now we only have, it means that the photon must be having this energy as well. So what you have to do is just convert this into joules. That's the only thing you have to do, convert this into joule. So you say, okay, it is 1.02 into 1.6 into 10 raised power minus 13, this one. So you end up with the answer, with almost the same answer, 1.6 into 10 raised power minus 13. Why? Because this is 1.02. That's why there's no big difference. So you got your answer. Okay, the next part is, on another occasion, an electron-positron pair is created by a photon with the energy of 2.1 into 10 to the power minus 13. Deduce how the energy is conserved in this occasion. So now they're saying that the photon which is coming over here is having this much of energy. And of course, it is hitting a nucleus. And now they're saying that if an electron or a positron are being produced, how energy will be conserved in this? Because we know that the rest mass energy is always constant. So rest mass energy is 0.51. And for both, you multiply them, so it is 1.02. And you have found that it was 1.6 into 10 to the power minus 13 joule in the previous part. So now what happened to this extra energy? So how much is the extra energy? First, you calculate how much is the extra energy, and then you subtract 1.6 into minus 13. I'm talking about this one, and you get 0.5 into 10 to the power minus 13 joule. And as there are two particles, so you divide it by 2, so 0.25 into 10 to the power minus 13. It means that this is the surplus energy for both of the particles, right? Okay, so what we say that the extra energy, which is total this, or individual particle energy is this, it is appeared in the form of kinetic energy of electron and positron. So we say that extra energy of 0.5 into 10 to the power minus 13 joule will appear in the form of kinetic energy of pair of particles. Like, what are the pair of particles? It's electron or positron. Okay, moving forward to next question, and this question is from forces. So this is from forces and momentum, particularly it is from momentum. So they're saying why momentum is a vector quantity. It's only 1 mark. So remember, whenever there is only 1 mark, you just have to tell the reason. Although they have written explain. So you'll be saying that momentum is vector since it needs direction along with magnitude and unit for its complete description. Like if you want to describe momentum, of course, you have to tell magnitude. Magnitude is value like 20, and then unit, which is Newton second. And then you have to tell which way it is moving, because momentum is vector. Why? Because momentum is product of mass and velocity. Velocity is vector. That's why we say that momentum is a vector quantity. Okay, moving on to the next part. This is again a confusing part, actually. Like in every paper, there are few parts which are very tricky, and the tricky nature make them challenging. So this is a challenging question. Why? Because it is represented in a tricky way. So there are two trucks, X and Y, and they are moving towards each other like the head-on collision, one with 6 meter per second, other with 18 meter per second. And X has a mass of 4.8, okay, and Y has a mass of 2.4, and their speeds are given. So Y is moving with greater speed, 18. That's why its momentum would be higher. The two trucks collided. Okay, show that truck X changes direction during the collision. 3 marks. So you only have to show that the truck X in this case is going to change its direction of motion, right? So what you have to do is you have to find the momentum actually. Okay, so as it is a three marker question, so it means it involves some calculations and then some concept to answer. Okay, so what we do is first, as you know that initial momentum is given. So what you do is initial total momentum. First, you find initial total momentum of this system. And you know how to find the momentum. The total momentum would be mx ux plus my uy. What you do is you added both of them, right? And this is like 4.8 into 6 plus 2.4 into minus 18. This is the important thing, that you should be using a negative sign over there. Why you should be using a negative sign? Because y is moving to left. So if anything is moving to left, we take it as negative. We take its velocity or momentum as negative. Okay. So now when you solve this, you get an answer of minus 14.4. I have to be quick in the calculation. I have the calculator with me. So this is the total momentum. So we say that the total momentum is negative. And as we know that law of conservation of momentum states that the total momentum is always conserved. So it means that as the momentum of y is greater, so we say the momentum of y is greater than momentum of x. So the possible thing is that truck x is going to move back. Only then you can have a final negative momentum, because this is the initial momentum. The final momentum should also be minus 14.4, and this is possible only if x rebounds. If x doesn't rebound, then you don't give then you don't get the negative momentum. Why? Because momentum to right is positive and momentum to left is negative. So if after collision both are moving to right, I mean, then how momentum can be negative? So that's why x should be rebounding. So this is one important reason. So we say that for momentum to be conserved, let me answer it now. So I'll be writing that for momentum to be conserved, truck X should be moving backwards. That's it. So that is your answer. 3 marks, 1 mark for the calculation, the second mark for this identifying that the momentum is conserved, and the third is concluding your answer. Okay, let's move on to this question, which is again a very tricky one and a different one. Like this was a different question. None of the question in previous years was like this. So this question is from radioactivity, but they have clubbed the errors from measurement in this. Okay, so first, if we read the question, we get to know that this figure should interpret as that the student is going to use to investigate the inverse square law for the radiation. You know the inverse square law? The intensity of the radiation is inversely proportional to square of distance from the source, and at times we write it as constant over r square, and at times we can write it as I is equal to kr square, or I is equal to I naught over r square. So this formula is provided in the booklet in the insert sheet, and in fact this is the one and only formula from atomic physics that is present in the insert sheet. I is the intensity at distance r, and I naught is the intensity at the source. So we say this is intensity at source, and you know that always remains the same. So that's why this k and I naught both represent the same thing. So this is related to inverse square law. The student uses a source of gamma radiation together with a radioactive detector to determine the count rate. Okay, so this is the radioactive detector. This might be the GM tube. You know, GM tube is a radioactive detector that has an inert gas of argon, and that through ionization of that argon, it detects the count rate, and this is attached to a counter that gives the reading in counts per minute or per second. Okay, so this is the gamma ray source, which is over there, and this is the detector. Of course, the detector is filled with the gas, and this is the distance between them. Okay, so what they're saying that the student uses a ruler to measure the vertical distance d between the top of the gamma source and the bottom of the radioactive detector. Okay, right. Student is doing measuring the distance d between the gamma ray source and the detector. Okay, but the question is explain how. Okay, so you have to explain that how the distance d in the figure is introducing a systematic error. Oh, okay. It means that some systematic error is there, and you have to look for that. You have to look for the reason why systematic error is there. Well, this is important. Systematic error is the instrumental error. It is the fixed error. So it means that there is some fixed error that is present over there. Okay, the first thought can be that maybe the ruler is uncalibrated, the ruler marking are not correctly calibrated over there, right? But the thing is that this is not the answer. Actually, if we look upon from where the gamma source is producing the radiation, if you look closely, if I just zoom in, so it's not that the gamma radiation are produced from the surface. Gamma radiation can be produced from anywhere within the source, and they are just measuring the distance from the top. One more thing, this is the radioactive detectors, and it detects the radiation with the help of ionization of gas. I mean, when the radiation enters the gas, it ionizes the gas and then they are detected. It means that radiation are not detected at the surface, but detected uh, within the counter. So it means that they are measuring the distance from the wrong place. And as they're always measuring from the top of the source to bottom of this, so that's why this always introduces a systematic error, which is the constant size error. So we say that we can write that we have to write the reason. So from the figure, you have to tell the reason. So the first reason is that gamma rays are being produced inside source, not from surface. I mean, they can be produced from the surface, but not always from the surface. Okay, so and being detected inside detector, of course, not on its surface. So that's why you are measuring distance from the surface, but they are being detected inside. That's why you say that D, or you can say the measure D, the D that you are going to measure. So this measure D will be shorter than actual distance. So as this is not introduced by the observer, that's why this is the systematic error. If you look upon the next thing, they are saying that you have to tell the steps needed to determination of the count rate accurately, like how you will measure the accurate count rate. Whenever the accurate word is there, it means you have to repeat your reading, repeat plus average, and you have to take average. And one more thing, that as these are the radiation, whenever radiations are there, radiations from the source, it means that these will not only be from the source, but some background radiations will also be there. So we have to mention both of these. So we will say that I'm using the abbreviation background radiation without source, like don't place the source and measure the background radiation, then measure the count rate several times and subtract background radiations and average. So what you have to do is you have to take two steps. One, you have to measure the background and subtract from the reading, and second, you have to repeat and average. So that's how you will get your answer. Moving on to the next question, which is question number 4, and this is from motion in line, and this is from the graph. So this seems to be a easier version of this paper. So this is a velocity time graph. Remember, whenever graphs are there, you have to look upon the axis, the values, the units, and in case any prefixes are there, so you'll have to look upon that. So first I'm looking here, this velocity is in meter per second, so that is perfect for me, no problem. But when I look here, the time is in milliseconds, so I will say that, I will mark that this m is milli, and milli is 10 raised power minus 3, so this can create a problem for me, so I have to look for that. Okay, what they're saying is, what's the question? The question is determine the average speed of the object during the time it is moving. During the time it is moving. Okay, that's really important. It started motion from here and it stopped here. So that's why this whole area represent the motion. But they're saying the average speed. So you know that the average speed formula is equal to, the average speed is equal to total distance, as they're talking about speed, so I'll be writing distance. Total distance over total time. Okay. Now there are two targets for you. One is the total distance and second is the total time. So the total distance is from area under velocity time graph or area under speed time graph, right? So you'll have to find this area. How much is this area? And then the total time is from x-axis. So total time is from x-axis, so you'll read from here. So the small square value along x-axis is, there are 10 squares and 5, so it is 0.5. So this is starting from 1, 2, 3. So this is starting from 1.5 millisecond, and it is going to end at 21 millisecond. So it means that this value of total time is 21 minus 1.5. So this would be 19.5 milliseconds. So this is the total time and this length as well. Okay, so you have to find the area. So as this is the trapezium, you can look over there. This area is trapezium. You can make it two triangles as well, like this. I'm roughly drawing it. So this is triangle 1, this is triangle 2, this is rectangle. You can add them as well, but it's better that you consider it as a trapezium. So the trapezium area is 1 by 2 sum of parallel sides multiplied by height, right? So you'll simply do that. So just keep in mind that this one is in millisecond. Just remember that. So P1 is 19.5. And you have to look for P2. How much is P2? So this is your second parallel side. It is starting from here and ending at here in the middle. So you have to look for that. So this is, as this is 7.5 and then 8 and 8.25. So this is 8.25. And if you look closely here, I'm talking about this. So we can say that this is 1, 2, 2.5 behind 20. Yeah. So this is like 19 and 18.75. This seems to 18.75. You subtract them. So you subtract 18.75 minus 8.25. So you will get your answer as 10.25. So this side is 10.25, if I'm not wrong. No, hold on. Yeah, it seemed to be wrong because, no, it's fine. 7.5, 8, 8.25. Yeah, that seemed to be perfect. So this is 10.25, and don't forget to multiply this with minus 3 because this is milli. And then the height, you have to look for the height. How much is the height? So height is along y-axis, every small box represent 0.1. So 3.1, 3.2. So it means that this is 3.2. So now what you have to do is you simply have to multiply them. Just multiply them to get your answer, right? So this distance comes out to be around 0.047 meter, right? Okay, and now we got it 0.047, and you divide it with the time, and that time is 19.5 milli, and milli is -3. And when you do that, then you will get your answer around 2.5 meter per second. So this is your answer. I'm just doing the rough calculation. Maybe this value should be a little bit different, and maybe this value is a little bit different, but your answer should be in the range of 2.4 to 2.6 meter per second. Okay, moving on to the next thing, the mass of the object is 0.54, and you have to determine the magnitude of resultant force that is required to bring the object to rest. Okay, so how much force is required to stop the object? So you should be looking at the graph that here the object is accelerating, okay, so it's having the positive value. Here the object acceleration is 0, it's moving with the constant speed, but here it is decelerating or being stopping, right? So it means that from here to here, the object is going to be stopped, like 18.75 second to 21 millisecond, it is going to be stopped. So all you need to do is to find this deceleration, and you can find it from the gradient. So we can say A is V minus U by T. V is 0, and U is 3.2, and time is 21 minus, like you are looking about this time, how much is this time? So this is 21 minus 18.75, so it is 1 2 3, so we can say 3.25 millisecond, and don't forget to multiply it with -3. So when you do this, so you will get some deceleration. Maybe we have to double check this. So I was talking about this one, how much is this time? So let's say, not necessarily this, it is actually, in reality, it is over here. So this is like 1 2 3 4. So 4 is 2 and 2.25, sorry. So this is a little wrong value. This is actually 2.5, around 2.5. Okay, so after finding this acceleration, like first you will find this deceleration over there, which is 0 minus 3, 2, and this is 2.5 into 10 raised power minus 3. And after doing this, you can use F equals MA. The A value is over there, so you can simply plug in both the values to get your answer. And your answer should be in a range of around 690 to 870 Newton. So this is simple. You just find the acceleration, put it over there, and multiply with 0.54 to get your answer. Okay, moving on to question number 5. This is again from radioactivity and its uses. Okay, so let's look upon this question. A solution containing a nuclide of technetium-99m is prepared for use in medical diagnosis. Okay, an isotope of molybdenum undergoes beta minus decay to produce a nucleus of technetium-99m. Well, that's how technetium is produced. So this is molybdenum, and it is emitting beta particle, and then it is converting into technetium. But what they're saying that you have to complete the decay equation for the 2 marks. Okay, that's perfect. That is one of the easier questions from the radioactivity. So as you know, this is beta negative. Beta negative. So you know beta negative is having a charge of -1 and its mass is negligible. Okay, and whenever beta negative is there, then anti-neutrino is there having no mass, no charge. So this is what? This is anti-neutrino. Remember one thing, if beta negative is there, then anti-neutrino will be emitting. But if beta positive is there, then neutrino is going to be emitted over there. This is point to remember, PTR. Okay, moving back, we know that the nucleon number and the charge number remain conserved in the nuclear reaction. So this is 99, this is 0, this is 0. So it means that this is 99. M is just the metastable state. This M stands for metastable state, which is coming in the next part. And then the charge number is also conserved. So this is 0 minus 1. So -1 is here. So it means 43 should be there because 43 minus 1 makes 42. So that's how you complete it. Okay, next they're asking you about the metastable state. So what technetium-99m is a metastable. Explain what is meant by metastable state. So you know the metastable state, it is actually the excited state, but the thing is that it is the state in which nucleus stays for longer time, because usually what happen is that radioisotopes have shorter half-lives, so they emit the gamma rays for very short time. But over here it takes some time for technetium to emit the gamma rays, so that's why we say that this is in metastable state. So we can say here that technetium 99m is in excited state, but it stays longer in this state. Usually that doesn't happen. Nucleus stays in excited state for a very short time before going to stable state. But here it stays over there for a bit longer time. Okay, and emitting gamma rays not immediately or for longer time. Like this is the state in which nucleus remains there in the excess energy state for longer period of time. So that is called metastable. Okay, next thing is related to the half-life. Half-life is 6 hours, and the initial activity, whenever initial activity is A, initial means AO. This is 384 megabecquerel. Becquerel is the SI unit of radioactivity, and it is also equal to per second. Sometimes it is per second, like 384 mega per second. They can write it like that as well. Calculate the time taken for the activity of the sample to decrease to this. So this is the recent activity. So you have to find how much total time it requires for the activity of 384 to go to 1.5. So there are two methods. Let me tell you the first method, which is the easier version. Okay. So let's say the initial activity is 384. So you try to half it. So when you half it, it is 192. Well, I have to rely on my mental maths here. Okay. And this one is 96. Well, which seems pretty much okay at this age of 44. Well, this is 24. This is 12. And then after 12 it is 6, after 6 it is 3, and after 3 it is 1.5. Here we go, we have to look for 1.5, and we found it. So this is the first half-life, this is the second half-life, third half-life, fourth half-life, fifth half-life, sixth half-life, seventh, and eighth. So it means that from A naught to A, or from 384 to 1.5, the total half-lives that are elapsed, we write it as n, are 8. So 8 half-lives are there. So we have a formula which is n equal total time over half-life time. So from here, total time is n into 1 half-life. Total half-lives are 8 and the 1 half-life is 6. So this is 48 hours. So this is our answer. Now, if you look at method 2, that is the equation method. If you are a maths lover, so this equation, this method is for you. Okay, so we have a formula A equals A naught over 2 power n. Okay, n is the number of half-life and n is total time over half-life. So these are the two formulas that you are going to use over there. So what you do is you have to find n, so you just replace these two and then just put the value. This is 384 and this is 1.5, and then you take the natural log on both sides, so natural log 2n and natural log 384 over 1.5. And you know that after taking natural log, n comes here, like the power value comes behind that. So you solve this and use the calculator to take natural log of 384 over 1.5, and then divide this with the natural log of 2, you get your n. Once you get your value of n, which seems to be 8, so you put that back over there in this formula, and that is actually pretty much same as this. So you will get your answer of 48. So you will write your answer of 48 hours over there. Moving on to the next part, the last part for this. A patient is injected with solution containing technetium 99M and detected outside the body. Okay. Explain how technetium 99M is appropriate nuclide for use in medical diagnosis. So they're saying that why this is appropriate, why you're using it. So first you have to look at why we use technetium, and it is, hint is, detected outside the body. This is actually the hint for you. You know, alpha, beta, gamma. Alpha and beta cannot come out of the body or even cannot go into our body from outside. It is only gamma ray that is having the highest penetration. Highest penetration. It means that gamma rays are the suitable for use in medical diagnosis, and as technetium 99M emits gamma rays, that's why this is the best source for us. And one more thing, it is emitted by technetium 99M, which is in metastable state. It means its half-life is little bit longer, so that the radiation can last longer in the patient to look for to be detected, right? But actually the half-life is not as long as the other natural radioactive materials, so that's why, like, it is a bit longer than the ordinary radioisotope, but it is of course shorter than the natural radioactive substance. That's why it will not be harming the body. Okay, so the main reason, if we write the answer, so we will say that technetium 99M is a gamma emitter, and gamma rays can easily penetrate out of body or come out of the body for detection. Okay, so this is the first thing. And second thing, we can write that half-life is not long enough that it damages the healthy tissues, but fairly high to be detected in a good time. Like, it's not that its half-life is few seconds or minutes, that as soon as technetium 99M gets into the patient body, so the radiation are gone. You need some time for them to be detected as well. Okay, now moving on to question 6, which is related to, again, forces. Okay, so this question number 6 is from the moment of force. So this is from moments. So the two conditions for equilibrium. This is a very famous question. What is meant by equilibrium? Equilibrium means that an object is in balanced state. Balanced state. And you know, the balanced state can be two. Either the object can be at rest or the object can be in uniform motion. And you know what is uniform motion? Uniform motion means that its velocity is constant or its acceleration is zero. So there are two conditions for object to be in equilibrium, either at rest or in uniform motion. The first condition is that the net force acting on the object should be zero. The net force means resultant force. So you can write a sentence that the resultant force acting on object should be zero, or you can write net force equal to zero. Remember, net or resultant both have same meaning. The next is net moment acting on object should be zero. So some people can write sum of anti-clockwise moment should be equal to the clockwise moment, or the other version can be resultant moment acting on object should be zero, or there should be no resultant moment acting about the point. Okay. Figure shows a child on the skateboard. The skateboard is in equilibrium. Remember, this is the key word, so you have to underline that. This is the keyword. So do underline the keyword. This is one of the important tricks of the paper, that while reading the question, you underline the keywords so that that can help you later in the question. The center of mass of the skateboard is at midpoint. Again, this is the keyword, so I am underlining it. So as you can see, that two forces are acting, F1 and F2 are acting upward. So these are the reaction forces. Reaction forces. Okay. And of course, the weight of this person is acting downward, and the weight of the skateboarder is acting downward as well. So they're saying F1 and F2 are the normal reaction forces, and the weight of the child is 360, and the mass of the skateboard is this. So this is the trick. They gave you the weight of child, but they give you the mass of the skateboard. So eventually you have to convert that. W is equal to mg, so 4.8 into 9.8. So you will have to convert that into the Newton as well. So in this comes out to be around 47. So it means that this is 47 Newton and this is 360 Newton. The center of mass of the child is directly above the center of mass. Okay, that's all the problem. It means that both of them are acting from the same point. So the total force acting downward is 407 Newton from here. So now they're asking you to calculate F1. So this is a very 2 marks, but you have to see that there is no moment involved over there. No moment. Why? Because this is at rest. The child is at rest. And as it is from the middle and both of these tires are at same distance, so it means that F1 and F2 are equal. So we say that F1 is equal to F2, or we can say F1 plus F2 is equal to downward force. So we can write as both of them are equal to F. So we can solve it as 407 divided by 2. So we say that F1 is 407 divided by 2 because the distance of the force is same from both the points. That's why you simply divide it with 2. So you will get 203.5 Newton. And if you have to write the answer, so you can write 204 Newton for it, because the sig fig are very important things in this. So you always have to write 2 or 3 sig fig in your answer if otherwise stated with any other number. Okay, moving forward, the child now changes position so that the skateboard is balanced. Again, it is balanced, and on a horizontal bar at P as shown in the figure, the skateboard is again in equilibrium. Okay, so here you go. It is balanced on the bar, but of course he has just shifted the weight now. The weight is different now. Figure shows the forces acting on the skateboarder and important distances. The bar at P exert a vertical force R on the skateboarder. The skateboarder is an angle of 15 degree to the horizontal. Okay, here you go, a detailed picture. So this is P point, which is the pivot. R is normal reaction force from here. Then from B, FB is acting downward. From A, FA is acting downward. This is most probably because of the foot of the child over there. Then see the skateboard. This is the skateboard center of mass. Center of mass. So here this is the skateboard weight which is acting downward, and the distance from P to A is 53, and distance from P to the end point is 65, which is the length of the skateboard. This is the length of board. Okay, now after examining, whenever a diagram is there, you have to examine that very, very carefully. Now we say that the child's left foot exert a vertical force Fa at A, her right foot exert a vertical force B, and they are giving you a relation. So this is a trick in this question. They told you that the child's forces due to the weight, of course, these forces are due to the weight, or FB is 11 FA. Now they are not equal. Previously, they were equal together, but now they are not equal. So, but we can say that FA plus FB, again, the force due to child, is equal to weight of child. We can write this. So FA is FA, but FB is 11 FA. So we can write 11 FA over here. That is equal to the weight of the child. That is 360. So we can write 12 FA equal 360 Newton. And we can write FA as 360 over 12, which is 30 Newton. Yeah, so FA is 30. So if FA is 30 Newton, what should be FB? So FB is 11 FA. So you multiply 30 with that. So that will be 330 Newton. So this is the important calculation that you have to do first. This is just based on this trick. So it means that 330 and 30 Newton, these are the forces. So this force is 30 Newton downwards and this is 330 Newton downward. This was our first step in this question. Okay, now moving on to the next. B is the horizontal distance from X, X from P, and you have to calculate X. So it means that this X is the distance, horizontal distance from B. This is actually perpendicular distance of FB. You have to find this. So now this is a moment question. How you know that this is moment question? Because the forces are given, the distance are given, and it is in equilibrium. So you'll be saying that sum of clockwise moment is equal to sum of anti-clockwise moment. So you will be doing this. Okay, so now there's a famous formula for this. Whenever you have to do moment question, so always remember P, F, D, Tom, which is type of moment, and EOM, which is equation of moment. So always remember this, always use this. These are the 5 points. So this is called 5 points of moments. Okay, so the first thing is that you have to look where is the pivot. You identify the pivot, so this is the pivot you have identified. Second is you have to identify how many forces are there. So this is force FA, this is mg, which is the weight of skateboard, which this is R, and this is FB. So every force is there. Sometimes the forces are missing. As 330 and 30, we calculated those forces. So we said, okay, we know all the forces. This is most challenging in most of the questions, the distance. And you know, this distance should be perpendicular to the force. This is symbol for the perpendicular, 90 degree. Like the distance should be perpendicular to the force. So for X, we know it is perpendicular, so it is easy. But the thing is, this mg and fa don't have the perpendicular distance. So what you have to do is you have to find their perpendicular distance. If you look, for A, the distance is 53, but this is not perpendicular because you know this is not the perpendicular. This theta is not 90. So that's why you can't use this 53. Similarly, this mg doesn't have any distance, perpendicular distance from the pivot. So what you have to do is you have to look for the perpendicular distance. So let me just erase this, and this is the most challenging part. So you have to be looking at this very carefully. I am just removing every other detail from here so that we can focus on how to find the distance. So we are finding the perpendicular distance of FA and C, which is the skateboard mass from the pivot. So this is our target. So first of all, if you look carefully that how much is the distance of FA, this is 53. So we say that distance from pivot to here is 53 centimeter. And this is at the angle of 15 degrees. So if I say resolve this, resolve into components. So we have to look for the two components. The first component is adjacent to angle. So this is the first component, and this component is 53 cos 15. And then the other component is sine. So we don't have to draw the other component. Why? Because if you look closely upon this component, this FA is coming down, FA, and this is the distance. So these two are at right angles. So this distance, 53 cos 15, is perpendicular for FA. So I'll write the perpendicular distance for FA as 53 cos 15. And now, similarly, I have to do this again. I'm going to erase this so that you can understand the other calculation as well. So the other thing is you have to look for the distance of center of gravity. Okay, if you look upon the center of gravity, this is total 65. So from this pivot to the center of mass, This is 65 divided by 2, which is 32.5 centimeter. So now again you resolve it. So this component over here is coming out to be 32.5 cos 15, because adjacent to it is cos. And then this mg is going down and it is perpendicular. It means the perpendicular distance for this is 32.5 cos 15. So that's how you found the perpendicular distance, and this was actually the only challenging thing in this. So you figured out the distances as well. Now type of moment. Type of moment mean whether it is clockwise moment or anti-clockwise moment. You have to look for that as well. So let me just erase that because we are done with this. And now what you do is you simply have to look for how many forces are there and what moment they are producing. So this is pivot. So of course, these two forces, Fa and mg, are going to produce anti-clockwise moment, right? And this R is not going to be produce any moment because it is passing through pivot, and this FB is going to produce clockwise moment. So we have identified that as well. And now at the end, you have to apply equation of moment, which is sum of clockwise moment. This is equation of moment is equal to sum of anti-clockwise moment. So you will simply apply over there. So sum of you can say clockwise moment is equal to sum of anti-clockwise moment. So the clockwise moment is produced by FB into X, and this is because of FA into 53 cos 18, if I don't forget. And then for the other one is the weight of the skateboard, which was 47, weight of the skateboard, because its mass was 4.8 kg, and then its weight was 47 Newton. So 47 into 32.5 cos 18. So these two values we just have calculated over there. Okay. So now you simplify it. And one more thing, we know that this FB and FA, we have already calculated them as well. FA was 30 and FB was 330. So you just put that and you solve for X. So you get your answer for X as, of course, you will have to put all the values over there to get the value of this X. So I have to do a little calculation in that. Let me just give a couple of seconds to do that. And if I use the calculator, so the answer is 9.1. So the answer comes out to be 9.1 centimeter. And you have to write it all the way over there. They have given you plenty of space to solve this. Okay, let's move on to the last question for this section. Figure shows the two forces acting on wheel of stationary racing car that is standing on a horizontal surface. Okay, this is the tire of wheel of a car. This is the normal force, and you know the normal force is on tire. And of course, this is by ground because this is the normal reaction force. And this is the weight of tire. So it means this is the force on tire by earth. This is the gravitational force. Okay, so it means both these forces are on the tire. Like the normal force on the tire, the weight on the tire. So they're saying the two forces are equal in magnitude and act in opposite direction. Okay, give one reason why the two forces are not action-reaction pair according to Newton's third law. Okay, so Newton's third law states that the forces exist in pair, and the pair is action and reaction. And second thing was they are equal in magnitude. So this is fulfilling it. Third thing is they are opposite in direction. Okay, this is also correct that they are opposite in direction. The fourth thing is they acts on different body, acts on different objects. It means that action is acting on one object, reaction will be acting on other object. So over here we can say these both forces are acting on the same body. So that's why these are not action reaction. And the next is that same type of forces should be there. Same type of forces. Like if one is gravitational force, you know weight is the gravitational force. the other should be the gravitational force as well. So which is not the case over here. So two reasons out of these two, you can write any one. So you can write that both forces are acting on tire. So not action reaction pair. Or you can say that both the forces are of different type. One is reaction force and one is the gravitational force. So that's why these are not action reaction forces. Okay, the other thing is during the race, the racing car enters a straight horizontal section of the track and accelerates. Okay, the driving force of the car is constant. Explain why the racing car reaches a constant speed. Why it reaches a constant speed? Refer to one of the Newton's laws of motion. Okay, so first, this question is a bit tricky. You have to understand this question very well. Remember, whenever they say explain or referring to law, so you have to understand the question very, very carefully. Read it again and again and try to understand the thing. So, whenever the racing car enters in the horizontal section, it means they're not moving vertically, not moving in circle. See? So this is not in circle. It is on straight track. So when the car is there, the driver is pressing the accelerator, the car is speeding up. As the car is speeding up, the air drag is also increasing, right? And then as air drag increasing, the resultant force decreases because the forward force minus air drag is the resultant force. So as the car accelerates, speeds up, the drag force increases. So this decreases the resultant force, hence its acceleration decreases. And a moment will come when the engine thrust and the air drag becomes equal. At that time, the car will achieve the constant speed. And this is, you can use Newton's first law, second or third, whatever, but you have to mention one of them. So let's try to write this answer. So we say that we will write it like as car accelerates, and this is due to force by engine, its speed increases. So this is the first point. The second point, I'm just writing with different things so that you can understand easily. Uh, we can write that air drag FD is proportional to speed. So this results in increase value of air drag. This will continue until drag force becomes equal to thrust of engine, leading to zero resultant force, right? So when the resultant force is zero, then we can say that according to Newton's second law of motion, now you can refer the law here, acceleration proportional to force. As force zero, acceleration is zero, and speed becomes constant. So this is the ideal way to write this answer. Okay, looking upon the next thing, well, this is a fascinating thing. A racing car is there with some flaps out of it. Okay, so they're saying that the racing car is fitted with a system that helps to overtake another car when the system is not in use, as in figure 8. So 8 is not in use. The flaps are positioned so that there is no gap between them. When the system is in use in the figure 9, this means it is in use. The flaps rotated so that there is an air gap between them. Okay, air gap, it is visible over there. This is air gap. Explain, again explain why using the system enables the racing car to overtake the other car. Okay, so this car has to overtake this car. So this is simple thing. You can see that when the flaps are closed, there is more surface area. So we say that closed flaps increases surface area, hence increasing air drag, right? and air drag is opposing force. So we say that, so opening flaps allows air to pass through it, as it is indicated by these small arrows over there as well, to pass through it, hence less drag force, resulting in increased forward force and acceleration to overtake the car. I mean, this was easy as well. Okay, let's move on to question number 8, which is the last question of section A. So figure shows a football player kicking a football. The initial velocity of the football is 15 meters per second at an angle of 38 to the horizontal. The bottom of the ball hits the top of the crossbar. Assume air resistance is negligible. Air resistance negligible means that acceleration is 9.81 meter per second square. Okay, so this is actually the projectile motion question. Projectile motion. So you can see here the footballer is hitting with 15 meter per second. This is the initial velocity and this is the angle. And this is the D. D is, you know, the range, the horizontal distance, and this is the crossbar. So, well, unluckily, it's a sad thing that it hits the crossbar and maybe it goes over there. It should be going into the goal. Anyways, better luck next time, you can say. So the first part is calculate the vertical component of the initial velocity. So this is from vector resolution. Vector resolution. So you can resolve the vector over there, right, on the diagram. So we can say that adjacent to that angle is cos. So this is 15 cos 38. And then the other component is here, which is 15 sine 38. So this is initial vertical and this is initial horizontal. So they're saying initial vertical. So you say this is 15 sine 38. And you will simply solve it to get the answer, that is 9.23. So 9.23 meter per second, or you can write 9.2 as well. The next is show that the maximum height gained by the ball is this. So you know the maximum height, the height is always by the vertical component of velocity. Vertical component of velocity. As there are two components of the velocity, so this vertical component is responsible for gaining the height. And as it moves up, vertical component started decreasing, and at maximum height, the vertical component is 0. So remember that whenever object is moving upward, its vertical component is going to decrease. Okay, so we know that G is constant, and in upward motion, G is always negative. Remember, whenever the object is thrown upward, its acceleration is negative all the time. Okay, so initial vertical component is 9.23. We just have calculated. The final vertical component at the maximum height is 0, and you have to find the height. So three things are there in the Suvite equation and time is missing. So we will be looking for a Suvite equation in which time is not there. So that will be 2as equal v square minus u square. So this is the equation that you identified based on the knowledge that time is missing. So you just have to plug in the values. So this is 2, this is g, this is h, this is vy square minus uy square. So just plug in the value. And before plugging in the value, the best practice is always to make the equation like this. Now plug in the values in this. This will save a lot of time of yours. So vy is 0, uy is 9.23, and then do 2 into minus 9.81. So when you do this, so you will get your answer as around 4.31 meters. Okay, moving on to the next part, you have to show that the time between the ball kicked and it reaches its maximum height is this. So it means you have to find time to reach max height. Time to reach max height. And again, for time, you always use the vertical component. Remember, for height and time, we use vertical component of velocity. For time and height, we always use vertical component. So again, filling in the data, we know that initial vertical was 9.23 meter per second. Final vertical at highest point, this is at highest point. It is 0. For this projectile motion, I have a really good video. I will be sharing the link at the end of this video. If you are having some compromised projectile motion concepts, I will be sharing the video over there. Do look at that video. That best explains everything related to the projectile motion. That will be a great help in your A-level physics. Okay, so now the maximum height we have already calculated, that was 4.31 meter. And as you have three things, and G is minus 9.81, this is the fourth thing we know, and you have to find the time. So you can use any equation in which time is there. So I will be using, based on this data, I will be using the equation of simple acceleration. A is v minus u over t, or t is v minus u over a, and then substituting these into the projectile equations, it's like this. So 0 minus 9.23 over minus 9.81, so gives you 0.94 second. Okay, the top of the crossbar is a height of 2.56. Calculate the time between the ball being kicked and hitting the crossbar. So this is the most challenging and the tricky question of this whole question. So this part is tricky. So they're saying 2.56. So it means that, referring back to this, they say that the height of this goalpost is 2.56 meter, and you have to tell that when they hit the ball from here, how long it takes to reach here. So this is the time that you have to calculate. And remember, you have already calculated the time to reach maximum height. That was 0.94 second. You're done with that. So just find the time from top to this, and then you add into that. So that will be your total time. So for time, we use the vertical component. So we say we will be starting from here. This will be our start point. Okay, so I'm going to draw this diagram over here. So let's say this is the crossbar, and this is the highest point. This is the highest point, and this is the crossbar. And we know that the total height that it gained was 4.31 meter, and this is 2.56 meter. So we have to look at how much it covers vertically downward from here. Like how much is this? So this is 4.31 minus 2.56. So this gives you the value. Okay, so let me just quickly look upon that. 4.31 minus 2.56, so that is 1.75. So this is 1.75 meter. So the height is 1.75. The initial vertical component over here is 0 because it is moving horizontally. So initial vertical is 0. G here will be plus 9.81 because now you are considering the downward motion. This is your start, and as the start point, it's going down. So it is plus 9.81, and you have to find the time. So you don't have final velocity. So this is missing. So as you have V missing, so you have to look for the Stewart equation in which V is missing. So in the insert sheet, you can see that on the second page of the insert sheet, the third equation, the third set of equations are equations of motion. V equal to U plus AT, V square is U square plus 2AS, and then S is U plus V over 2 into T, and then there is equation S equal UT plus half AT square. S is UT plus half AT square. This is not having V, that's why we are choosing this. Convert this into the projectile one. When I say convert, it means you are replacing U with uy, a with g, and s with h. And now you have to put the values. So you know that the height is 1.75. This is 0, gone. 1 by 2, 9.81, and t square. So now from here onwards, you will look 1.75 is 1 over 2, 9.81 into t square. So shift this to other side, 1.75 over 4.905 equal t square. Take its root and you will get the answer. So when you get the answer, you have to add 0.94 into that as well. Why you have to add? Because the thing is, this is just the time from highest to this, and from previous it was 0.94 second. So this time comes out to be 0.6 second. So this is 0.6 and 0.94. You add both of them together. So your answer will be 0.6 plus 0.94. It will be 1.54 seconds. So this is the total time. Okay, the ball travels a horizontal distance d before hitting the crossbar. What is d? So the horizontal distance is by horizontal component of velocity, and that is constant. That stays the same everywhere. So that's why you use horizontal component is distance over time, and then this distance is horizontal component of velocity into total time. So horizontal component of velocity is how much? It is over here, which is 15 cos 38, and it remains same everywhere. So we say it is 15 cos 38, and the total time you just have calculated, it is 1.54, the total time taken by the football to hit the crossbar, right? So this comes out to be around 18 meters. So 18 meters is the distance. Okay, the last part, to calculate D, it was assumed that air resistance is negligible. Describe the effect of air resistance that will have on flight of the ball. Like if the air resistance is there, how that is affecting. So let me tell you this through this, that without air resistance, it was like this. But if the air resistance is there, then obviously the ball would not be reaching to the maximum height and it will be feeling short as well, and then its horizontal component, it will be falling vertically as well. So whenever air resistance is there, three effects are going to happen. So we can say that air drag reduces, number one, air drag reduces max height gained, like the object will not be able to reach the max height. And then number two, range, it reduces the range as well. It fell short of the original bar. And number three, it reduces horizontal component of velocity as well. Horizontal component of velocity. And horizontal component of velocity at the end becomes zero. So that's how this effect, air resistance has effect. So this is end of section A. Now in the video 2, I'll be looking upon section B. And in the video 3, I'll be looking upon section C. And I'll be adding the additional supportive videos as well. And I will be sharing their link as well. Thank you so much, everyone. I hope this was a useful video for you.